Good afternoon. I'm thrilled to be able to present to you a project-based learning unit that I've created. I love project-based learning, and I'm going to tell you why in this presentation. But let me just say that probably the most exciting thing to me about it is how authentic it truly is. And we're going to see what I think is a very authentic unit. It has to do with a particular type of class in career and technical education that I think really strikes at what can be great about project-based learning. It doesn't have to just be for the more traditional academic subjects. It's terrific for all sorts of different types of classes. Now, the particular class that I've been doing this for is actually a Tennessee course in information technology track. And the information technology track course specifically is the networking systems course. And essentially what I've done in this unit is to create a project-based learning experience with the idea of how do we make our school's Wi-Fi faster and or less costly. Again, this is in the networking systems class, which is the third course, the third class rather, of the information technology track in career and technical education in the state of Tennessee. So the driving question in this particular unit is this: how can we make our school's Wi-Fi faster and or, hopefully and, less costly? That's a pretty big driving question. And so as with any good project or inquiry-based learning, we need to help the students get their arms around that question and then build their own questions off of that driving question. So that's the next thing, is how do we get our arms around a big question like that? And interestingly enough, just a few days ago, the New York Times Magazine ran an article that I think speaks to the heart of it. And the article was titled, "New Technology is Built on a Stack. Is that the best way to understand everything else too?" The great thing is for our students to begin to get their arms around the question of how do we improve our network. Happily, the answer actually is in the stack. Now, the reason I say the answer is in the stack is because, first of all, we have a stack model that is actually one of the standards for this course. Tennessee CTE Networking Standard 7 says the following: create and use diagrams to explain the open systems interconnection, OSI model, and the flow of data through it. Define the functions and identify the associated hardware components of the OSI model's following 7 layers. Yes, it is a 7-layer stack model. And if that sounds pretty nerdy, guess what? It's really, really useful. In fact, the OSI model is a stack model that has been used now for nearly 40 years, and it is the model upon which all of modern-day networking for computers is built. We would not have the internet, we would not have the ability to associate computer technology the way that we do today if it were not built on the OSI model and everybody agreeing to build on the OSI model. The OSI model itself really allows us to take a very keen engineering-oriented view of the way networks work. And the amazing thing about this model is that it serves a bunch of different purposes. A network engineer, for instance, can take this model and show you as information passes from the application layer at the top at your computer how in every point along that stack, all the way down to the physical layer, which is the wire or the air across which the packets travel from one system to the next, they can show you how each particular layer of the stack adds something onto that original data in order to make it transmissible reliably from one computer to another, and be able to work, once it gets over there, to be able to be deconstructed and brought back into the system where it's traveling to, and then maybe even onto more systems. So that model's terrific for that, but it's also terrific from a systems engineer's perspective, because a systems engineer can look at each layer of that stack, look at the hardware and the software that's involved in each of those layers of the 7-layer stack, and isolate ones in that stack and say, where can things be better? Where can we have better efficiency? Where do we need to change things and bring in newer technology? And it is in this role that, in fact, our students can get their arms around the idea of being able to work with a question as big as, how do we improve a network? In fact, what we can do with students is we can say, okay, guys, here's what you're going to do. Once we've gone through the model, you have a good idea of what it is, we're going to ask each of your teams to choose one layer of the model and research and propose a solution for making our network better out of that layer of the stack. And so, for those of you who are familiar with project-based learning, in fact, it is the network stack itself that actually becomes the model under which we can have student voice and choice. Students can choose a solution of their own to research, and there are plenty of those solutions out with the network stack. They might, for instance, choose at the application layer of the stack to say, hey, you know what? Maybe the biggest problem that we have on this network is all these students with their phones updating their software all the time. That brings in a lot of data from outside, and that's costly, and it also slows down our network. What if there were, for instance, a thing called a caching server that could stay on our network, that could keep all of that data local and cut our costs for bandwidth and cut our the amount of time it takes things to come in from the outside to our network? That could bring in a whole new level of both speed and cost savings. Same thing could be true, though. Another group of students might go down to the network layer and they might say, hey, you know what? Maybe there are some new protocols that make our iOS devices, our iPads, and our phones work better with the Cisco networking. Maybe we need to look at that. Or maybe they'll say, well, you know what? Our equipment's kind of outdated. Well, that brings us down to the data link layer. And at the data link layer of the model, they might say, hey, can we replace equipment and make our Wi-Fi significantly faster? All of those might be great solutions. And there's a number more. That's the great thing about working with the model in this way. We don't have to force students into one choice. And that, of course, is exactly what we want. We want students to do their research, make their own choices, and then pursue those choices with solutions. And the great thing is, working with the model in this way helps us to be able to do that. Now, to be fair, once you've made a decision like that, you're still going to need a lot of help with research. And so one of the things that we'll also be doing in this particular course is getting help from the experts. So we'll give students white papers from folks like Apple and Cisco that describe modern day networking and how modern day networking can be improved, so that they'll have a place to go once they've made the initial decisions of what it is they want to share with one another, but rather they want to share with the audience in their proposed solution. So they'll be able to go in and really research and dig and come out with something great. So let's go in just for a moment, dig down just a bit, and let's talk about the roadmap for this unit. What is it that we're going to be doing? And this is a 2-week unit or 10 classes. So what are we going to do in these 10 classes? Well, essentially, the first thing that we're going to do on day one is we're going to introduce the problem to the students, and we're going to create the small teams that are going to be, these might be teams of 3, 4, 6, depending on the size of the class. We'll create those teams and assign them. The second thing that we do then on day 2 is this is where we do the direct instruction of the whole class on the OSI model. And then once they've heard that, the whole class will brainstorm some of the ideas about solutions that they might get from the different layers. And so they're all going to work together at that point. Once that's happened, for day 3, students are going to do individual research that evening perhaps, and then the teams are going to come back together on day 3, and they're going to choose one layer. Each team will choose a layer to explore. It doesn't have to be different layers. They can all just choose, if they need to choose the same one, whatever they have and they think is great. They're going to be given, at this point, they're going to be given tools. They're going to be given rubrics for using the tools, and they're also going to choose some team roles, because we're going to have different roles in the team. Some folks are going to create a solution proposal. Some folks are going to work on creating the media that's going to go with the presentation. Others will be the presenters. So we can have all of those different roles and have room for a number of different folks on the team. On day 4, we've got it planned out for teams to discuss their individual research with one another. And it's at this point as well that we may have some teacher guidance, or hopefully even some consultants from the community, if we can find them, to come in and sit down with the students and just see if they've got even a halfway viable solution. Again, it's not a big deal that these solutions be fantastic. In fact, the big thing that we want to do is we want to get it into process and help the students understand what they can and can't do in general, and then to build on that. On day 5, teams will refine their solution and they'll prepare to create the proposal itself. And the solution proposal is a 2-page proposal with, again, with a rubric to guide students into exactly what needs to be included, probably including something a little bit about cost at least, and a little bit of detail on what their network solution is going to be. On day 6 then, going into the next week, on day 6, the teams are going to finalize and assemble their solution proposals. On day 7 and 8, they're going to refine their presentation ideas, and then they're going to create appropriate media to, whether it be the original presentation slides or perhaps even video to accompany those slides. That's day 7 and 8. On day 9, then we have the teams actually do their proposal and presentation to stakeholders, and this is where we involve folks in the community. We certainly want district IT, because we'll make the point to the students that if it works in this school, it will work across the entire district. So we want to get folks from the district's information technology group. Hopefully, we're in an area where we can actually pull from some industry vendors, maybe even some network installers. A lot of even smaller, more rural areas will have network companies or the phone company that will actually do network installs. And so all of those people could be reviewers and commenters for the student presentations. And then finally, day 10, as we always want to do with project-based learning experience, is day 10 is a debrief and both personal and team reflection. So that's the general roadmap for the 2 weeks of the unit. I think there are at least 5 things that I see right away that were so useful in this unit. The first one is that it brings the learning objectives to the students very naturally. It's not just something the teacher assigned. They understand even something as geeky, frankly, as the OSI 7-layer model has meaning when it helps them understand what it is that they are using it for. So we love that. It also is useful because it incorporates cross-disciplinary student learning objectives. Students have to present. They have to write a proposal. They've got to create media. All of these pieces are integral to the overall learning objective of the unit, but they're also getting those objectives met that really work across all kinds of disciplines. So it's useful for that. The third thing, and I alluded to this earlier, students are getting to choose their own path for exploration. And obviously, that's what we want them to do. And that's what they want to do. They want to not have something just assigned to them. They want to learn it for themselves. Fourth great outcome of this is that students actually see the real-world impact of a solution. They actually begin to make the connection between this conceptual idea of a network model and how it is that it lets people understand how to fix or make their world better. So that's also a fantastic outcome. And then the last one, and one that's near and dear to my heart, is that it mirrors business learning. One of my favorite jokes ever, and I know this is dumb and a dad joke, but what do they call Canada geese in Canada? Geese. In a world full of projects, in the business world full of projects, what do you call project-based learning? Learning. This is the way it works. But not only that, the way that this unit is set up, it also mirrors business practice. We take an idea like the network map that we have here. We take an idea like the network map, which is totally conceptual, and through the work to propose a solution and present it, we turn that into a business practice. That is the ability to actually take this to a point where someone derives benefit from the theoretical to the real. Folks, thanks so much for listening, and thanks so much for observing this presentation. I hope there are ideas that you can take and use as you build units like this for your students. Thanks very much.